All right, everybody, we're gonna do a special video here. We had a request for um, a video about this topic, completing the square and finding the center and radius of a circle algebraically. So, what are we going to be doing today? We're going to find the center and radius of a circle that's written out in algebraic form. How we're going to do this is we're going to take the expanded form of the circle equation and we're going to complete the square so that we can turn that equation into standard form. And the reason why we want to be able to do this is because standard form is so much easier if we're trying to find the center and the radius. You can actually just read it right off of the diagram, which is really great. So in order to be able to do this, the very first thing that we have to know is the perfect square formula. Because if we have something of this form, then we can rewrite it as a plus b squared. So if you've got a squared plus 2ab plus b squared as the thing that is in your possession, you can take that and rewrite it as a plus b squared. Or if it's a squared minus 2ab plus b squared, you can have a minus b, the quantity squared, and you can use the same idea for both. I personally just always go for this one. The negative signs always come out in the wash anyway, so it's not a big deal. But if you are the type of person you would like to remember that there are basically two formats, that's fine too. You'll get the same answer regardless of how you do it. Now, when you are given a circle equation, sometimes that circle equation is going to be written out in what's called expanded form. That means that it's all the terms are written out like this, where you've got the two squared terms here, the two linear terms here, and then you'll have a constant term, and then it's equal to 0. So in order to do this, so first of all, we're going to have to remember I'm going to put it up here in the corner, a squared plus 2ab plus b squared. I'm getting close to my head, so I'm going to try and duck down a little bit. Okay, so from here, all we are going to do is we are going to basically, we're going to treat this like it's two separate problems. We got the x terms, we got the y terms, and we're going to complete the square twice for both of them. So the very first thing you want to do when you're given something like this is let's take this constant term and get it out the way. Let's move it over to the other side so that it's not in our way. So we're going to have the 336, we're going to subtract it over to the other side so that we have space to work. So we're going to take all our x terms, we're going to put them over here. And then, I'll do a little thing. We'll have our y terms. We'll put those over here. And one thing to be very clear about is that you absolutely 100% do not need to do all of this at once. You can break this problem down into two whole separate problems out of context, and then you can bring it all back together at the very end. Just for ease of space, I'm writing it all out on the same line, but I'm going to do the x one first, then I'll do the y one, and then we'll put everything back together. So, remember what I said, the formula that we want to conform to is a squared plus 2ab plus b squared. And the important part here is that your a squared is always this first quadratic term, the x squared. So a squared is x squared. And then if we solve, because we want to find out what a is so that we can sort of propagate the rest of our diagram, right? So we're going to square root both sides, and so a is going to be the same as x. That's pretty simple. But what it also means is that now this negative 24x, that's the same thing as our 2ab. And we already know that a is x, right? So we can just plug that in. And now we can find what our b is. Well, let's divide both sides by 2x and get rid of all that. And that leaves us with b is equal to, I'm going to flip things around, negative 12 here. So now we have our a and our b. Well, everything is a and b, right? So can't I just plug everything in? A squared plus b plus 2ab plus b squared. So we've got x squared plus 2 times a times b, 2 times x times negative 12, so negative 24x plus b squared, 144. So the only thing that's different from my orange line here and my green line here is the fact that there needs to be a plus 144 here. And if there's a plus 144 on this side, I have to make sure that both of my sides stay the same. So I've got to, if I add 144 to the left of the equation, I have to add 144 to the right of the equation. And now, remember, this is the same thing as saying a plus b squared. So now I can come down here where my final answer is going to go, and I can say, well, a plus b, well, that's x minus 12, the quantity squared, and now I've done my x. I've completed the square here. Now I'm going to do the same thing for y. So again, I'm going to look at my first term, and that's my a. So I know that here my a is going to be y. Now I can figure out that 2ab is the same as negative 28y. Now I can put my y here, that's where that goes, right? So we got 2yb equals negative 28y. Now I can just solve for b, divide both sides by 2y. And so b is negative 14y. And so now I've got my a, now I've got my b. Not 14y. What am I doing? Silly. Negative 14, right? And so now I've got my a, now I've got my b. I can just put it right in here. A squared plus 2ab, 2 times y times negative 14, so minus 28y. And then 14 squared, negative 14 squared is 196. And so once again, you know, I look up here, what's the difference between this one and this one? Just this last term. It's always going to be just this last term. So I'm going to add 196 over here. I'm going to add 196 over here. And bada bing, bada boom. And then I just have to add all this up, right? So we've got negative 336, we've got 144, we've got 196. Let's add these two together. I don't feel like trying to do something. So we got 340 here, that's 4. We got 336 here. 340 minus 336 had better be 4. So now I've completed my square, and the second half of this problem is what's the center, what's the radius. So remember what I said, you can read it just right off here. Flip the sign here, this is your x value, so the x value of the center is 12. Flip the sign here, that's your y value. The y value is 14 for the radius, and then square root this, so center, and then radius is just the square root of whatever this is, 2. So Here is your standard form equation. Here is your center. Here is your radius. So there's that problem. I've got a bunch more. We're going to go through them. But here's the next one. So go ahead. I'm going to say pause the video, try it on your own, make sure you're capable of doing it. And then once you unfreeze, we'll continue. Okay, so once again, I'm going to divide my page up just so that I have everything. I'm going to move the 69 over here. So we got our x terms. We've got our y terms. And we're just gonna do it. So you got y squared minus 14, or x squared minus 14x. And so our a is going to be x. Hopefully that's pretty clear. A is usually going to be x when the coefficient here is 1. And then we're going to find 2ab is the same as negative 14x. And well, x is a, so you know, if it helps, you can just sort of scrooge it out, and then so b is going to be negative 7. So now a squared plus 2ab plus b squared. So we got x squared plus negative minus 14x. And you know, you should expect the first two terms to always come out right. You know, should expect that the first two terms come out right, and then you can just take the b, square it, and you get 49. We're going to put a plus 49 over here since there's one over here. And we're going to break it down. And then we're going to do the same thing with our y. So we've got y is going to be your a. And hopefully, you know, you're starting to see the pattern. 6 is going to be your b. So 36 is going to be your c squared, your b squared. And then we can say, all right, well, so y plus 6. And then we can go through and we can say, all right, well, this is 70, 85. So this is 85 minus 69. You get 16. Awesome. So there's your completed, squared. There's your completed standard form equation. Your center is at 7, negative 6. Just remember, whatever number's in here, you take the you just change the sign. And then the radius is at the square root of this number. It's 4. So this problem here, we hopefully, since we're seeing the patterns, we can kind of buzz through this a little quicker. So what, for our x terms, we're gonna, you know, negative 28 means that our b is negative 14. Square that, we get 196. We got x minus 14. We do the same thing with our y's. And again, I'm always going to put this constant term on the other side. And then same thing. It's the same number, so we better also have 196 here too, right? And so this breaks down. We've got x minus 14, the quantity squared, right? This will be y minus 14, the quantity squared. And then we added 196 and 196. We better add them over here too. And then we're just going to combine our like terms here, the 196. Let's add those together because this is hard to just sort of do. So we got 392, and we're going to subtract 367. And I think that's 25. And so there's your standard form equation, and again you can just read it right off. Change the sign for your x value, change the sign to find the y value. There's your center, then your radius here is 5. All right, let's do one more, and again let's go through this quickly. So x squared minus 18x plus, divide by 2, you get negative 9, square that, you get 81. Do the same thing with your y. Divide by 2, square it, you get 100. And we're going to have this already waiting here on the other side. And we got to add the 81 and the 100. And so we end up with 181 minus 145, which I think if I see it should be 36. So we end up with x minus 9 squared plus y minus 10, the quantity squared, equals 36. And so again, center and radius. Center is 9, 10. Radius is 6. Now, the problem I was sent when I decided to make this lesson, the problem that was sent looked like this. I want you to notice slightly different numbers. We haven't really seen any odd numbers yet. And that doesn't really change the problem so much as it just means that fractions are going to happen, and that's okay. So let's do the exact same thing. We've got x squared plus 7x. Divide by 2 and square it. That is 3.5 is our, so automatically I'm reaching for a calculator because I don't have time to take 3.5 and square it. That's okay. So I look over here, I'm just going to do it 3.5 squared. I get 12.25. I'm going to add that to the other side. And also you notice that this is a negative 3, so when we add it over here, there's a plus 3. So there's my x part. We got x plus 3.5, the quantity squared. Now we're going to do our y part. And once again, you know, it's an odd number, and that's okay. So we're going to divide by 2 and square it. So 5.5 squared. Because I'm not going to do that in my head. And I really don't want to do it on paper either, to be honest. 30.25. I'm going to make sure to add that up here as well. And so when I simplify it down, I get y minus 5.5, the quantity squared. Now let's collect all this. We've got 30, 3, and 12. That is 45.5. When you add all this up, that looks right. And then when you do 45.5, you want to find the square root of that so you can find your radius, right? So let me move you out the way to where you matter. So I want to see that 45.5. I'm going to raise that to the 1/2 power because I don't feel like looking for the square root button. And then you get that ugly number. That doesn't look very good, does it? So we've got some options. If we don't want to, or we're not told to give an answer rounded or something like that, we can rewrite this as 91/2, and we can just square root it that way. If you do that, when you square root, so the radius, let me square root of 91/2. And now, if you wanted to rationalize this, I don't think you normally have to later on. The context of this is it's in a calculus course. By the time you get to calculus, you're not required to like rationalize the denominator anymore. Nobody cares about that. But in high school, I'm sure they would make you. And this is a question you might see in Algebra 2 or Pre-Calc. So you square root the whole thing. That's the same as square rooting both the top and the bottom separately. Rationalize the denominator. So we've got a rationalized answer of 1/82 in the radical over 2. So that's your radius, which is 6 something. And then your center is negative 3.5 is negative 3.5 comma 5.5. And that's it. Have a good one. See you next time. I'm covering the work I did over here. Let's show that real quick. So rationalizing means multiply the top and the bottom by the radical down there. And then this right here is your final answer, radical 1/82/2. Okay, have a good one. See you around.